Hey everyone, I'm sorry I couldn't be there with you today. I'm a little bit under the weather and at home in my pajamas. But today we're going to be talking about periodic models. I will try and keep talking to as much of a minimum as possible. So hopefully you can follow along with what's appearing on the screen. Today we're talking about the applications of trig functions, particularly sine and cos. These are models that are periodic, meaning that they have a certain increasing and decreasing pattern and that they happen at repeated intervals. Some of the things that you can see in the real world include monthly temperatures in a city, a person's blood pressure at rest. Tidal motion is an awesome one, so are the sunrise and sunset patterns over the course of the year. These are all examples of trig functions in the real world. There are so many others, but these are just some of the few. In any case, we're going to talk about a rabbit population first. Notice that the population is in thousands. You're going to want to either underline that or circle that so that you don't forget. It's modeled by the equation that's given. Notice that time is from 0 to 24, and t is measured in months after the 1st of January. So first it says, what is the largest population predicted by this model? Well, if I look at my principal axis is y is equal to 12. My amplitude is 3. Therefore, the largest possible population that I can get, or the maximum, is 12 plus 3, which is 15. Because the population is in thousands, it is 15,000 rabbits is the largest population. Next it says, how long is it between the times when the population reaches consecutive peaks? Basically, it's asking for the period. So the period, one cycle for a cos graph is 360. There's 30 right here in front of the t, which is what I'm going to divide by. That means 12 when I divide. Therefore, it takes 12 months to reach consecutive peaks. Just in case, you also need to know that 12 months is a year. Fantastic. Then it says, what is the longest span of time for which r of t is greater than or equal to 13.5? What it's asking me is the following. When is the function that I just have at the top of the page, 12 plus 3 cos 30t, greater than or equal to 13.5? Well, I can have a couple of options. One, I can sketch and have a little sketch, or I can use my calculator, and when I use my calculator, I can get a sketch from that. So if I use my calculator to sketch, I'm going to go to my calculator. I'm going to put in the equation into the y1 button, 12 plus 3 cos 30t, or 30x as the case may be, and then 13.5 into my y2. If I was going to make sure that my mode would be in degrees as well, I'm also going to change my window. Now, let's think about it. If my principal axis is 12 and the amplitude is 3, that means the highest that it goes is 15 and the lowest that it goes is 9. So when I go to my window, I'm going to go from 0 to 24 like it told me at the top. I'm going to go up by 2s, for example. I'm also going to make my y minimum 8, which is 1 less than the 9, and my y maximum 16, which is 1 more than the 15. And I'm going to go up by a scale of 1. I'm going to hit graph, and this is the graph that's going to appear. I can sketch this graph on my page. So this is the graph that I have on my screen, and this is the one that I have on my page. Basically, what I want to find is where this happens and this happens, because the span of time from here to here is the longest span of time that it's above 13.5. Now, sorry, if I go here, I'm going to want to second trace. I want to find the intersection, so number 5. I want to be before that on the first curve, the second curve. I want to let it guess. It's going to tell me 10. I'm going to do it again for the second intersection point over here. So second trace. Number 5, intersect. I'm going to go over closer to that intersection point over here. Hit enter again, let it guess, and it's going to tell me 14. So basically the longest span of time that the population is above 13,500 is 4 months. Okay, so let's look at now the temperature over a 24-hour day in Mathville, and it's modeled by the following population. If you don't like the way it's written, change it to something you can use, or that something that is similar to something you're comfortable with. So -6 cos 15t plus 18, where t is at the time in hours after midnight. So what is the temperature at midnight? At midnight, basically, time is nothing. Time is 0. So I want C at 0. So that's -6 cos at 0 plus 18. Well, cos at 0 is 1. So that's -6 plus 18, which is 12 degrees Celsius. I want to know the temperature at 2 p.m. 2 p.m. is 14 hours after midnight. So I want C at 14. -6 cos 15 times 14 is 210 plus 18. That's, if I use my calculator, I come out with 23.2 degrees Celsius. Now if I want the maximum and minimum temperatures, the maximum, if the principal axis is 18 and it goes as high as 6 and as low as -6, I add 6 to get 24 degrees Celsius. And that's 18 minus 6, which is 12 degrees Celsius. So I know that my temperature fluctuates between 12 and 24. It then says graph this temperature over the 24-hour period. Well, if 18 is my principal axis, and 24 is as high as it goes, and 12 is as low as it goes, and it is a cos graph, it's -6, so it starts down here, 12. 24 hours later, it's also 12. Halfway in between, at 12 hours, it's 24. At 6, it's 0. And at 18, it's also 0. If I didn't know a 24-hour period, just to confirm, that's 360 divided by the 15, which gives me 24. Now here's where we start to get a little bit more involving. It says here, at what time is the temperature 15 degrees Celsius? So -6 cos 15t plus 18 is equal to 15. Isolate, we get -6 cos 15t is equal to -3. So cos 15t is equal to a half. Now, all of a sudden, it should remind you, oh my god, this is a special triangle. So you say to yourself, if this is 1 and this is 2, then this is 60. So that means that in the first quadrant, it's 60, so 15t is equal to 60. And in the fourth quadrant, 15t is equal to 300. Therefore, t is equal to 4, and t is equal to 20. That means 4 a.m. and 8 p.m.